Sorry about that, everyone. I had a little technical difficulty, so let's wrap up this last problem. So number 4, we've got the sequence that goes 20, negative 10, positive 5, negative 5 over 2, positive 5 over 4. Just like before, a little trial and error. If we think about just moving from one term to the next, are we adding, are we subtracting? I mean, this is really weird here. You're subtracting by 30, but then you're adding 15. So again, there's definitely no good addition or subtraction that works. And now maybe if we really think about the geometric idea, we'd look for the pattern and go, 20 divided by negative 2 gives me negative 10. Negative 10 divided by negative 2 gives me negative 5. And then that continues. So maybe we notice that there's a consistent division and that we are dividing by negative 2. So a little similar to what we had with arithmetic. The idea of adding or subtracting consistently goes with an arithmetic sequence, similar for geometric, multiplying or dividing, but for arithmetic, we always had to treat it as addition, so subtracting by 3 is the same as the same thing as adding a negative 3 consistently. So here in number 4, the idea of dividing by negative 2 is the same as multiplying by negative 1/2. And that's the way we have to think about it. That is how we get our R value. But of course, the formulas still help. I pointed out any of the subtraction you do up here, and notice I stuck with the whole numbers. I didn't try and mix the fractions in with that. But when I tried to do the subtract a term minus its previous, I wasn't getting anything good. But now if I try and divide, well, negative 10 divided by 20 is negative 1/2. Positive 5 divided by negative 10 is negative 1/2. Keep going, negative 5/2 divided by 5. Do a little work with your fractions, you'll get negative 1/2. And same even with this last one. So it is geometric, R is negative 1/2. So now we continually multiply by negative 1/2. 5/4 times negative 1/2 would be negative 5/8, and then negative 5/8 times negative 1/2 would be positive 5 over 16. I would have no problem at all if you use decimals instead, especially if you're seeing the divide by negative 2, you could make that a negative 2.5. That's a positive 1.25. So you can use it with decimals. You'll get, what is that, negative 0.675, and that, 5 over 16. And that would give us 0.3125. I'd be fine with the decimals. Again, they're not necessary here. The fractions are just fine. Just to realize either way, that is what we're looking for. So again, that's it. Lots more. The book goes into, again, the ideas of series and adding them. And if you look past 11.5, starts talking about the binomial theorem. So there's a lot of other information in chapter 11, but that ends what we need to know. The basics of sequences, a little bit of notation, a little bit about using the general term formula to find other terms, a little bit about factorials, and then just being able to distinguish between arithmetic and geometric series, getting the R or the D value, and getting the next couple of terms.